Right, hello students, welcome back. And we are starting chapter 6 here. Okay, well, I should say students or anybody else that may be listening. But in chapter 6, the focus is to start off, the first couple sections have to do with functions. And then later on throughout the chapter, we're going to be focusing on radicals, how to simplify radicals, how to graph a radical function, a square root function, how to solve equations that have radicals in them, things to that nature. Okay, but again, just focusing on functions today, which is all stuff that we've done before, so just almost as a review. Operations on functions, when I think of operations, I'm thinking of, addition, subtraction, multiplication, and division, which is basically all we're doing here. Okay, so for these first few examples, we have two functions. We have f of x, we have g of x. So f of x is just 2x, g of x is negative x plus 5. We have to perform all the four operations. So addition is the first one. We're just going to be adding. So there's two ways you might see it written. It might be presented to you like this. It says f plus g of x or f of x plus g of x. They mean the same thing. All you're doing is you're going to take those two functions, f of x and g of x, and add them together. So I'm going to take f of x, so 2x. I'm going to add to it g of x, which is negative x plus 5. So how do I add these functions? Realistically, all you're going to do is combine like terms. So if I add, the only like terms we have is 2x, we're adding a negative 1x, so that's 1x. And then plus 5 just stays by itself, so x plus 5. And now for the next one, now subtracting. So next subtraction, again written one of two ways. Okay, these mean the same thing, but the key thing with subtraction is you want to make sure you do it in the order that it's saying. So it's saying you want to take f of x and then subtract from it g of x, which is negative x plus 5. Okay, so we're subtracting g of x away from f of x. So you want to make sure you have it in the right order. Again, what I would probably do, since it's subtraction for this one, I would distribute that minus sign because you're subtracting negative x, you're also subtracting 5. So we're really doing 2x plus x, because that'd be a negative negative x, and then minus 5, which is going to be 3x minus 5 is our final answer. Okay? Next, multiplication. So now we're timesing. So we're going to take these two functions, again, written one of two ways. Just going to multiply them. So we got f of x. We're timesing it by g of x. So how do I multiply these together? Just distribute. So take that 2x, distribute it to both terms. You'd have a negative 2x squared plus 10x. There you go. And the last one is division. So dividing now, again written one of two ways. Okay, and again, the order in which you do these is key. It's saying to do f of x goes on top, and we're dividing it by g of x. And there's really nothing you could do division-wise for this one, so we can't actually divide the monomial by the binomial, so it's going to stay just like this. Okay, the only time you could really do anything is if you can possibly factor something and then get something to cancel the top and bottom. But nothing's going to factor, nothing is cancelable for this one. But if you do have a denominator with a variable in it like we do here, negative x plus 5, you'd also kind of want to stay off on the side, what can x not be equal to? So basically, what makes this fraction undefined? What would give me 0 on the bottom? What would x have to be on the bottom to make that all 0? Well, in this case, x could not be 5 because if x were 5 on the bottom, you'd have negative 5 plus 5, right? And negative 5 plus 5, that is 0, which would be bad because that would make this an undefined fraction, which we can't have undefined fractions. Okay, so again, technically my answer, like I said, is the first part, what I circled. So this is my solution. But again, if you have a variable on the bottom of your fraction like we do for this one, you also want to state what can x not be equal to, what gives me an undefined fraction. Okay? Now, doing the same thing, it looks like, same four operations, but now we have two new functions. So here's f of x, here's g of x. So first one, we want to add. So we're just have f of x, which is x squared minus 4. We're going to add to it g of x, 2x plus 1. So to add these two together, again, combine like terms. So that'd be x squared plus 2x. The only like terms we have are negative 4 plus 1, and we get minus 3. Okay, so we add it, now we're done. Next one, number 2, now we're subtracting. So f of x goes first. X squared minus 4, we're subtracting from it. 2x plus 1. Again, I think it'd be helpful to distribute that minus sign to have x squared minus 4 minus 2x minus 1. Now just combine like terms, so x squared minus 2x minus 5 is our solution. Okay, the next one is multiplication. So f times g, so we're doing x squared minus 4. We're timesing that by 2x plus 1. How we multiply these two binomials together is by FOILing, okay, or double distribution. So we're just going to take this x squared, distribute that to both terms first. So that would give us 2x cubed plus x squared, and now distribute negative 4 to both terms. That'd be minus 8x minus 4. And there's your answer, okay? There's no like terms, so that would be it. And now the last part is division. So f goes on top, g goes on the bottom. So f of x on top, that would be x squared minus 4. And that's going to be over 2x plus 1. So like I said before, with division, the only time we can actually do something is if we can factor and cancel. Where the top is actually factorable, my numerator, I can factor that into x minus 2x plus 2. But it's not going to really lead us anywhere because, well, nothing's going to cancel, right? Everything's still going to be all intact. I don't have an x minus 2 on top and an x minus 2 in the bottom. So realistically, I can leave my answer just like this. Okay, if you want the factored answer as well, you could circle that one as well. I'm sure your teachers wouldn't mind to see that. But the last and final thing, like I said, if you have x in the bottom, if x is in your denominator, you also want to say what can x not be equal to? What makes this fraction undefined? So the question is, what makes 2x plus 1? What makes my denominator equal to 0? That's the question. So if you don't know just by looking at it, just kind of set it off on the side here like I did. 2x plus 1, set it equal to 0, and now just solve for x. Well, you'd want to subtract 1 and then divide by 2. So if x were to be negative 1/2, that would give me 0 in my denominator. So in this case, the one value that x cannot be equal to would be negative 1/2 because that makes my fraction undefined. Okay? Same thing for the next one. So we just got two new functions again. We got f of x, we got g of x, so f and g. So now f of x is going to be a trinomial, so it's getting a little bit bigger here. So we're doing f of x, and then we're adding to it g of x, x minus 1. So combine like terms, 3x squared. See, negative 2x plus 1 would be negative 1x. And then negative 1 plus a negative 1 would make that negative 2. And there you go. So now subtracting, we got 3x squared minus 2x minus 1. We're subtracting from it all of g, which is x minus 1. Again, distribute. So 3x squared minus 2x minus 1 minus x plus 1. So combining like terms, we get 3x squared. This would be a minus 3x. And then negative 1 plus 1, those actually cancel. So my answer would just be 3x squared minus 3x. Okay, now moving on to multiplication. So we got f of x, 3x squared minus 2x minus 1 times x minus 1. So again, just basically distributing for this one. So 3x squared, distribute that to both terms. So we'd have 3x cubed minus 3x squared. And I like to cross it out once I'm done with it. Okay, so now I'm going to take that minus 2x, distribute that over to both terms. So I'd have minus 2x squared plus 2x. So I'm done with that one. And now distribute negative 1 to both terms. So minus x plus 1. Clean it all up. Combine your like terms. They're right next to each other. So minus 5x squared plus x plus 1. And there you go. Last but not least, so now division. So on top we got f of x. So that's 3x squared minus 2x minus 1. On the bottom, that'd be x minus 1. So I would want to check and see, can I factor that top? Is this factorable? So let's check it out. I know the bottom can't factor anymore. That's just x minus 1. But can we factor this by guess and check? So it'd be a 3x and an x. It'd have to be 1 times 1 to get that minus 1 in the back. Is this going to be factorable? It looks like it is. Okay, looks like we got it factored here. So again, if you FOIL those back together, you'd have that 3x squared minus 3x plus 1x. That's how you get that minus 2x. And then 1 times negative 1 gives you negative 1. Okay, in this case scenario, these x minus 1s would cancel. So your final answer from division would just be 3x plus 1 on top. Okay, so in this case, you don't have to actually state what can x not be equal to because you don't have x left in your denominator anymore. Okay, so if I don't have an x anymore in my denominator, I don't have to worry about it. All right, final answer would just be 3x plus 1. Or even if you wanted to, you can kind of put into what we did in the previous chapter. If you did division, you could always do long division. So with these two, you could actually do long division or synthetic division and come out with the same exact answer as well. Okay, so keep that in mind. But moving on, what we got over here? Now we're doing compositions of functions. Okay, so this could also be written one of two ways. They mean the same thing. You could have kind of this little open circle in between, okay, but how you read that, that says f of g of x, and it could also be written like this as well, f of g of x. So like I said, how you read it is over here. This is how it translates, f of g of x. Okay, so again, given two functions, here's f of x, here's g of x. I'll show you how to do a composition. Okay, so the first one, we're doing f of g of x. So again, another way to write this might be written to you. This is kind of more so the more formal way. I'd say most of the time this is how you kind of see these compositions written. You don't really see it written this way with a little open circle, but you have to know that they both mean the same thing. Okay, how you do a composition. This says f of g of x, right? That means you're going to take the g of x function, and you're going to plug it in to f of x everywhere you see an x. So again, I'm going to take all of g of x, which is 4x, I'm going to plug it in over here into f of x for that x. Okay, so when you swap it out, when I take out this x and replace it with 4x, I'm going to have 2 times 4x minus 5, and now simplifying, get 8x minus 5. So just simply multiplying 2 times the 4x, now you're done. Okay, so moving on to the next one. Now we're doing the opposite. Now these two are flipped. So we're doing g of f of x. So now we're taking f of x, we're going to plug it into g. So doing this just vice versa. Flip it around. So now I'm taking all of 2x minus 5. I'm going to plug it into this x. So f gets plugged into g. So I'm going to have 4 times 2x minus 5. And now to simplify it, just distribute, you'd have 8x minus 20. And there's your answer. Okay, now it says we're going to do f of x. So that means we're going to take f of x and plug it into itself. So how do we do that? Well, 2x minus 5 is going to be plugged into that x into the 2x minus 5. So we're going to have 2 times 2x minus 5 minus 5. So distribute 4x minus 10 minus 5. And then just combining, you have 4x minus 15. And there you go. Okay, same thing for the last one. We're doing g of x. Again, another way to write this, g of x. These mean the same thing. So now take g of x, plug it into itself. So that's just 4 times 4x, and you just have 16x as your final answer. Okay, so more compositions for the next part. We've done ones pretty similar to this. Okay, so let me just kind of explain what we're doing. Two functions, right? F of x, g of x. We have to find f of g of 3. So where you want to start, you always want to start in the innermost parentheses. Basically, find g of 3 first. Okay, so finding g of 3. That means you're taking 3 and you're plugging it into g of x for that x. So when you plug in 3 into g of x, you're just going to have 3 squared, and you get 9. Now take this answer, plug that in now to the outside function, which is f. So now we're taking 9, we're going to plug that into f of x. So now I'm finding basically f of 9. So that's 2 times 9 minus 3. So 18 minus 3, you get 15. Okay? So for the next one, same idea. Two functions, starting on the innermost, you want to find f of 3 first. So f of 3 is 2 times 3 minus 3. So 6 minus 3, we get 3. Okay, now take that answer, plug it into the outside function, which is g. So now I'm plugging in 3 into g of x, so I'm finding g of 3. So that's just 3 squared, and your final answer would be 9. Okay, 15, the next one. Start by finding g of negative 5. So g of negative 5 is just doing negative 5 squared. That's positive 25. And now take that, plug it into f. So we're doing f of 25. So that's going to be 2 times 25 minus 3. That's 50 minus 3, and we should get 47 is our final answer. Okay, and now switching it up, just doing the opposite, find f of negative 5 first, and then take that, plug it into g. So f of negative 5, that's going to be 2 times negative 5 minus 3. So that's negative 10 minus 3, which is negative 13. Now take that, plug it into g of x. So we're doing g of negative 13, which is negative 13 squared, which is going to come out to positive 169. Okay, so again, the second one is truly your final solution. Okay, that first part, the first circled answer, just kind of gets us to what we have to do next. Okay, the last part, going back to compositions here. So we have three functions. We got h, or we got f, we got g, and we also have h thrown into the mix. Okay, so the first one, if we had to find f of g of x, again, that means take g of x, plug it into f of x, the whole function. So g plugged into f, so 2x minus 1, plug that into f of x, you're going to have 4 times 2x minus 1, which is 8x minus 4. And there you go. 18 now, the next one. Now we're going to do the opposite, plug f into g. So f plugged into g of x would be 2 times 4x minus 1. That's 8x minus 1. So you see the difference, right? These two problems, although they're very similar, 17, you're plugging g into f, and then we plugged in f into g. You can even see how the answers come out similar, but still somewhat different, obviously. Okay, so just make sure you read the problem properly. So for 19, now we're going to take f, we're going to plug it into h. So h is all the way down here, x squared plus 1. So f plugged into h would be 4x squared plus 1. Okay, so we're squaring the whole monomial of 4x. You have to square each term, making that 16x squared plus 1, and now we're done. Okay, and the last one, now we're going to plug g into h. So g of x plugged into h of x would make that 2x minus 1 squared plus 1. Okay. Again, when you square a binomial like 2x minus 1, you can't just square both terms. It's not like a monomial. It's not like we did back here where you just square both terms and then you're done. When you have a binomial squared like 2x minus 1, you have to FOIL this with another 2x minus 1. You have to expand it out and actually multiply these two together. Okay, so if you multiply 2x minus 1 times itself, you get 4x squared. So it'd be minus 2x minus 2x, so minus 4x plus 1 plus 1. So we get 4x squared minus 4x plus 2 is our final answer. Okay, and at the bottom here, again, we got three functions, the same three that we had up here. F of x is still 4x, g of x is still 2x minus 1, h of x is still x squared plus 1. Now a little bit trickier, okay, with three functions. If we want f of g of negative 1, again, start with g of negative 1. So plugging in negative 1 into g, you have 2 times negative 1 minus 1. So negative 2 minus 1, you get negative 3. Now plug that into the outside, which is f. So now we want to find f of negative 3. So 4 times negative 3, final answer, negative 12. Okay, for the next one, h of g of 4. So again, find g of 4 first. So g of 4 is 2 times 4 minus 1. So 8 minus 1, we get 7. Plug that now into h. So we're doing h of 7. 7 squared plus 1. That's 49 plus 1, and our final answer would be 50. Okay, next one, f of h of negative 4. So again, find h of negative 4 first. So we're doing negative 4 squared plus 1. That's 16 plus 1. We get 17. Now plug that into f. So we're doing f of 17. So 4 times 17, multiplying these two together. Let's see, that'd be 28, carry the 2, and that would make that 60, so 68. So final answer, 68. Okay, next one, g of 7. So we're going to find g of 7 first, and then plug that answer into g again. Okay, so g of 7 is going to be 2 times 7 minus 1. So 14 minus 1, we get 13. Now plug 13 back into g. So g of 13, is 2 times 13 minus 1. That's 26 minus 1. Final answer would be 25. Okay? Coming down to our bottom row where they get a little bit tougher. So we want to find f of 1/2 to start. So f of 1/2 is just doing 4 times 1/2. So half of 4, well, that comes out to be 2. Now take 2, plug it into h. So h of 2 is 2 squared plus 1. So that's 4 plus 1, and we get final answer would be 5. Okay? These last two. So now we're using all three functions. Okay? Again, you want to start on the very inside first and foremost. I want to start with this. Find f of 2. Once we know what f of 2 is, we're going to plug that into g. Once we know what that answer is, we're going to take that and plug it into h. Okay, so it just kind of expands its way out. But again, just start with the f of 2. So f of 2 is just 4 times 2. We get 8. Okay, now take that, plug it into the next function, which is g. So now finding g of 8. So that's going to be 2 times 8 minus 1. So 16 minus 1, we get 15. Now take that, plug it into the outermost function, which is h. Now we're finding h of 15. So we're doing 15 squared plus 1. So 15 squared, if I recall, I think that's 225 plus 1. So final answer is 226. Okay? So same thing for 27. First, just find h of 2. Find that first. So I'm doing 2 squared plus 1. So 4 plus 1, we get 5. Now I'm going to plug that into the next function, just working my way out, which is g. So g of 5 for the next one is 2 times 5 minus 1. So that's 10 minus 1. Getting ahead of myself here. 10 minus 1, and our answer would be 9. And now take 9, plug that into f. Last and final step, finding f of 9 is just doing 4 times 9, and we should get final answer of 36. Okay, so there's our operations with functions. Again, adding, subtracting, multiplying, dividing, and then you've also now seen compositions of functions. All right, so if you have any questions for us, just let us know. Otherwise, thank you for tuning in, and we'll talk to you guys later.